was assigned to you. We are a researcher from the University of Hertfordshire, based in Hatfield. And today we present a specific perspective on the workshop, which roots in our current research concerning the design of spatial environments through the lens of bodily movement. We are architecture designers by education, so considering what we have been talking today about, it's possible that we can see and look at things for a smaller scales, and probably through, let's say, indulging in otherwise insignificant details. So while I'm going to introduce the framework this study referred to, try to exemplify how architect manipulates wayfinding as a design matter, Davide will introduce key studies and link to cognitive decline in elderly, with the intent to define criteria for design urban setting. Shall I go to this? The approach to design of spaces, we as architects tend to often focus on designing the experience of the spaces rather than the space itself. And for this reason, we refer to phenomenology that in this case can be described as the study of experience, but also the study of how we build experience. This includes not only the passive experience of a sensory perception. This includes imagination, thought, emotion, desire. In short, includes everything we live through or perform. As architects, we design knowing that built environment can reinforce or transform people behavior. And with this in mind, we started looking at the neuroscience with the scope to understand how the behavior is the result of neuronal activities. And in this diagram, I try to look at the mechanism linking perception to behavior. Specifically, the diagram aims to show how decisions are strongly driven by emotions. So we start, we know, we start by activation of the sensory system. So we start with a sensory activation that generates a reaction in a kind of a neuronic. I needed to find a bit of a fantasy to imagine neuronic activity happening in our brain. And this leads straight away to body states that in the definition of Damasio are basically emotions. Through a neuronic system, I'm trying to simplify here, of course. These body states migrate to our brain, which is like, I imagine it like a blender, where there are other information, our experience, our language, our background, so a number of other ingredients that together with these inputs, transform these inputs, pure emotion into feelings. That is what we assume to be the cognitive experience happening at the brain level. And this leads straight away to generate a decision. So, of course, there are some aspects like some particular stimulation, like the sensation of falling, that cannot go too much into is a blender, because the body needs straight away to react, to make a decision. And what is relevant for us this context for us is really focalized on the first part of our diagram, which refers to the perception of that. And what we found very interesting is to look at the perception system as the sum of the external sensory system we know, the eye, the ears. But what is really relevant for us is understanding that we have also an external, internal sensory system, which relies in the motor system of our body. So if we look at this particular case, we see that in our discipline as architect, in reality, looking at the motor system is a key element when we are designing a space. In Castelvecchio, Calenzappa, by defining its different way to navigate the space, is engaging the user through his navigation system to his movement. And the reality, as architect, again, I need to stress it inside, when we modify surfaces, reality, we do it with the intent to trigger action, like opening a door or undertaking stairs, reaching a different levels. So, the limited indication of the motor system intended as a way to experience the environment is particularly fruitful in this context. It implies that the spatial experience is a way to support orientation, is a means of orientation. And if we look at this image, where the action is the action of a climbing, it's absolutely easy to understand, intuitively understandable, that there are potential actions in embodied in space. In this case, it's an architectural component, it's a stairs. So, and that is what we do. We manipulate this architectural component in order to activate, and we work around this potential action that is embodied in this component. We define that is the definition of affordance. We know that affordance is the potential action embodied in object and in component. This is an example that was the Biennale some years ago. Studio looking specifically to affordance is experimenting a way to work while standing. Instead of it was an experimentation about let's support the idea of working in a more dynamic way. So how we can create, of course, that was in the context of a Biennale, but how we can create opportunity to lean in instead of sitting while shaping these object while the user can interact in a different way. But again,
let's say more generally, it's about the fact that when you liberate, let's say, the design action, taking into consideration only the affordance, the concept of affordance, you end up having strange shapes, basically, because the shape suggests an act.
And in that case, it's about how we can manipulate the internal space in order to design the affordance. In this case, about how we can interact with an external facade, which creates engagement and this kind of action. These are sketches from this British architect, Gordon Fuller, and who is saying that the city should be designed from the point of view of moving people, since we apprehend the urban environment through kinesthetic experience. So for us, it's like saying, in reality, we have been doing that since ever in our discipline. It's now that we are referring to other disciplines, and probably the reason why we are here in some way is to see how other disciplines, scientifically based, can create opportunity for us to tailor this experience around our user. And in the second part of today's presentation, we focus on a specific kind of a user.
Thank you, Giuseppina.
Very well.
So, given this framework, we stress that we are architects, so we are quite different. Oh, yeah. But the study focuses on the architectural scale. So the architectural scale, as we intended, is the scale of the building, is the scale of the relationship between the body and architecture. Okay, which is a lot more wide scales, like scale or detail scale, but we are in the middle between them. And we're looking at how the design of urban public spaces can facilitate orientation in the elderly. We are at the architectural scale, but in the urban space. Okay, so we are referring at a rougher level of detail than the level of technological detail, but we still are talking about urban space, so the relationship between different buildings. So the consideration of diverse cognitive abilities due to neurodiversity and aging, especially aging, is a crucial aspect when designing buildings and urban environments. So we take into consideration two opposed navigation strategies. We have already seen that in Professor Shawana's presentation. So the egocentric, which is based on embodied presence in space, like in the first sketch, and the allocentric based on an orthogonal mental representation of a space usually known as maps. Okay, so we create a mental map of buildings of urban spaces, and that's the allocentric strategy, navigation strategy. So Moffat-Resnick explained that the allocentric strategy becomes more difficult with aging because of difficulties in organizing mental maps. So it becomes less easy to build mental maps once you age, and while in the same age group, women are even more likely to resort to contextual embodied information, so to the allocentric system. So this is because the hippocampus, which is vital for creating cognitive maps and integrating information for navigation, is subject to age-related decline, making the use of cognitive maps more difficult. The consequence of increasing spatial disorientation. So in particular, aging leads to the decline of spatial memory and navigation, and talking egocentric navigation strategies are preferred in any age group. However, the two navigation strategies are complementary. So still, even if it's more difficult while aging, it's been found that the two strategies are complement each other. So from this point of view, while designing for the elderly can simply entail a lower number of nodes, the first strategy is to use a lower number of nodes and a generally low interconnection density, ICD. The exploitation of the egocentric orientation strategy would maximize the success of the design, in particular, the presence of landmarks. We've been talking about landmarks, helps supporting egocentric navigation. So now, how are we looking at landmarks? So typically, are intended as non-repetitive, visually stimulating elements. So in order to investigate what a landmark is for in the context of elderly navigation, and then interaction with allocentric navigation strategy to a higher degree of definition, we employ two case studies. So the first is the Hogewijk, a dementia village in the Netherlands, which are these two maps, and is designed expressly with the aim of fostering autonomous orientation capabilities in peculiar users. So in this case, we see how a low interconnection density, so we have only 4 nodes, okay, so it helps, of course, the navigation, but the designers also applied a hierarchy between different paths. So we have different dimensions of the path and low interconnection density. Also, additionally, they used also different materials. So if we zoom in, we look even at the scale of the detail, the different materials are used to suggest and to reinforce, say, the ability of the users to recognize different paths and different places. So they use materiality, colors, and width of the paths all together to affect the egocentric representation system, which doesn't affect the allocentric system. from these close-ups, so we can appreciate how the elements that affect the egocentric representation are designed to facilitate recognizability from the users. A fundamental aspect is that the designers actively employ elements that exploit affordance and the proprioceptive system of the users. So the benches are elements that to a certain extent attract the users of the village. They can rest into it, they can gain more precise knowledge, and they can establish a relationship between the body and the object. So once they sit, once they see the bench, they remember how the bench feels like, and this is easier for them to, in this way, to recognize different benches in different locations. So this connection between the motor system and memory. So the motor system facilitates the role of memory, which is declining because of the hippocampus. So in the case of Milton Keynes, this second case study, we look at Milton Keynes main mall. We have a really simple layout, but the number of nodes is really high. You can see. So from the topological point of view, it's much more complicated. So the allocentric system here is made more difficult. But let's have a look at the close-up. And from the exterior, we have a number of elements that trigger the affordance, such as the benches. And so potentially the proprioceptive system can be activated by these elements, but they are very repetitive. They are always the same, and this affects how the users can remember them. So we are generally, even in the interior, we are generally lacking elements that activate the relationship between the motor system and space. And again, the same repetition and absence of elements that trigger a motor system response becomes apparent even in the sternocogniate. In interior, the benches, we have some benches, but they can potentially trigger the proprioceptive system. But the fact that they are not positioned at the nodes, so that this is something that also Lynch has already been cited. Says, okay, in order for it to become a landmark, it should have a relationship with the node, but they are not positioned in the nodes, and they're all the same, they're all equal. And so there is not a topographic relationship can enable the users to use the allocentric system, not a differentiation between the benches, different benches that can help use the egocentric system. So the few possible landmarks, like the clock, for instance, are often distant from the nodes and placed sporadically and do not contribute in activating the motion engagement of the users. So as a conclusion, we have created a taxonomy, of course, of these elements of this design strategy. So it's very operative as a research. In the end, we have a series of design strategies that can help designers to relate to certain specific users. So the overall planning plays a role in mitigating this orientation with low number of nodes, of course. But architectural elements of space must take into consideration factors that activate the egocentric orientation strategy. So among these design elements, we identified objective elements like repetition and topography, and subjective, such as the affordance that depends on age, cultural aspect, etc. Of course, a bench is not the same for a kid and for an elderly. Okay, so environmental affordances are crucial in the design of spaces that needs to address orientation of elderlies. Thank you.